Speaking of, show me a worksheet.
Different professions.
Yeah.
Also, you need incentive. You need
What's that?
incentive. They just earn more money.
It was I think they should first. Yeah.
It's such a.
Out. They're responsible.
I'm just not.
Something about space. Like, I think so. I think I do not love that. You can't reach the one.
I'm still trying to catch up and stuff, so I'll show you. I'm gonna show you. This is the best spoil it. Oh, you'll be. That's so sad. Yeah, ours is more about this. It's Democratic candidate.
That's a group that's trying to like stick electrons.
You're more similar to where I'm standing.
I'm
Sure.
realistic. So, and then eventually, like, you know, in at the right moment, but it takes days, like, maybe 5 minutes. So they would have to run from one side of the campus to the other side of the campus.
Like 30 minutes. Oh, first grade. That's like. Yeah. The key is, I'm gonna start it right. You also know, like, Woodrow Wilson was also massive in procrastinators because he was it's a bit. I thought it is more. He claimed to be inspired, but in like this room paid. Like something that's like compared to like just at least a little better. That's all that matters. Still wasn't like this age.
I could also go to, I would become like Franklin, what?
And we also censorship, you know.
That's like. Answer that. I'm testing.
Good and bad. Yeah. Definitely. Like you ever for that cold.
I could do all day. I didn't do it.
No, the one like Bible.
Because I didn't. Technically, I didn't die. Can I dictate something?
I'm not here. Oh, yeah.
Like ice creams, like you tried to.
Like Harvard and Dale.
I'm not gonna make a
Bar.
I'm not making a comment, right? I'm not commenting, I'm not making a comment.
My brother does. The bad. Like an Indian, I brought that up and everyone.
All right, from worksheet 2, are there any questions that you guys have for me? Okay, yeah, which page? Page 7. Okay, so with these types of problems, we're always just going to go through a ratio test, and we're just going to set up our conditions for convergence, which is that the limit of the a sub n divided by, the limit of the a sub n plus first divided by a sub n is going to be absolute value is less than 1, right? We know that's the condition. And we're just going to go through that condition until we can get x by itself. So here's my a sub n plus 1. Here's me dividing by my a sub nth term, which is multiplied by the reciprocal. Do the cleanup. All the n's should be resolved. The only thing left is your expression in terms of x. X is not touched by n, so that is going to remain. But then we're here with absolute value of 7x minus 3 is less than 1. Very good with this. Okay, so now the idea is that if we know that as long as we can find an X value that fulfills this condition, we know that we're going to get a converging series because we're still within the condition of convergence, right? Absolute value is less than 1. So we should figure out how to solve for X. So this is always going to be set up, well, with absolute value removed, we can set that expression to be between -1 and 1. And then to solve for X, we can add 3 to both sides. We can divide by 7 to each of the sides, and we get 2 7s and 4 7s. So now we know that for sure, anything between 2 7s and 4 7s is going to be absolutely convergent, right? There's no questions there. Okay. The question could be maybe 2 7s and 4 7s could be conditionally convergent, and these are the only candidates that we have to worry about for conditionally convergent. Because anything outside of it has no chance of converging, but there could be a possibility that this could be a less than or equal to, but we don't know. Because right now this is, we're just, we haven't tested the endpoints. We just know for sure what's in between is going to be convergent. So we just have to test 2 7s and 4 7s back into the original series and see if we get something that is a conditionally convergent series. If it is, then we will say conditionally convergent, like a alternating harmonic series. Or if it's diverging completely, then we just ignore it. It's not going to fulfill that condition. Okay, so are we good with that step so far? Okay, so if I plug 2 7s in, I'm going to get -1 to the n over n, and that is converging, so I can keep that. But if I plug in 4 7s, yeah, I did not show the step for that. But if I plug in 4 7s, I will get 4 minus 3, which is 1. 1 to the n over n is a harmonic series, so that is a diverging series. So 4 7s is out, only 2 7s is going to stay. Yeah, I should put the work in for 4 7s just to show that I'm comparing these two. Good. Any other questions?
If you solve one to be correct, you have to evaluate the other one to show you over.
No, because the answer choices kind of gives it away. But if it was not multiple choice, then we would need to test both, because it could be that neither of them are conditionally convergent, one of them is, or both of them are. So they're independent of each other. We should be testing both of them. But you're right. I mean, if we just got one and we already see that's the answer choice, then it's got to be that one. But we really should be testing both if it was. Yeah, and the next half section that we're going to do with Unit 10, we are going to have to test both sides. Any other questions from worksheet 2? All right, so I want you guys to spend class period today working on worksheet 3. Just know that today's going to be the last day that we spend class time going over test review, or sorry, quiz review. So if you have any questions, make sure you get them answered. But I'm not going to have the quiz the Wednesday we get back. I want us to kind of have a but I don't want to lose a day of instructions, so I'm going to start the next section, the next packet of notes. It will be the last set of notes, last set of new content. We'll be done with all of our new content by early March, because we're going to start studying for our test review. Not next week, but the week after. Okay. But our quiz will be on Thursday. I'll have help sessions Wednesday morning, Wednesday afternoon, and Thursday morning if you need it. Guys, I think I'm going to make the quiz calculator, but you have to show all your work. Okay, so show all your work like if you don't have the calculator, but you can use your calculator just as safety net if you want to check anything. Oh, right. Yeah, so I would say just always start with a limit comparison test, and if you're stuck with it, if it doesn't quite work, then just. There's always one. Okay. Not always, but sometimes they don't have everything. This one.
Student, how does, on the worksheet, three, how does number 6 converge to 1?
This one here.
Yeah.
Yeah, let me go over this one here.
I was thinking of like combining a fraction and doing LCT, but that'll take too long.
Yeah, yeah. Guys, yeah, I'm glad you asked that question because number 6, there's another series called telescoping series. I'm not going to put it on the test, but I think just on the quiz, but I do want to kind of show you this series because this is commonly included in as conversion test, but it's not technically a topic on the AP exam. So for number 6, you see how there's that 1 over 2 and -1, -1 over 2 and +1. It kind of has that staggered relationship where you don't do anything with it. We just kind of test and just understand that if we test out different values, let's say we start off with 1. If I plug in 1 in, I'll get 1 over 1 minus 1/3. Right? If I plug 2 in, I'm gonna get plus 1/3 minus 1/5. Plug the third term in, I get plus 1/5 minus 1/7, plus 1/7 minus 1/9. What's happening here? Right, so every second term is going to end up showing up as a positive for the upcoming n value. And we call this a telescoping series because it just contracts into just a sum that is easy to tell. Because if we go to infinity, technically, all these sums are going to start canceling each other out. And the only thing that remains is, after we go through the first few terms, we're going to be able to get to the one that, if there were some terms remaining, we'll be able to tell by after third and fourth term what remains because we can tell everything after will cancel out. So in this case, this just ends up being
Yes, if you think about, natural law, right? Natural law goes like this. So if any function is heavy, that means it's like someone breaks that. Then it goes to, then you get to 1 over. And it goes to 1 over. That's getting closer and closer towards the X, Y axis. And it's gonna get head down towards infinity, right? Yeah, so this is.
We have the ones.
Right.
Yeah.
Yeah.
I think last.
Sure. I found another room, actually.
I'm just heavy set of that. So, like, move this steps. If I have, I want to find a limit, some efficiency. This would be case of 1 plus 25. But a partial sum is accumulating that already, so if I want to find a sum in partial sums, it's already accumulating into accumulated in here. So if I want to find sum of the series, it's just the limit as of infinity of the partial sum. Yeah.
If the first one reaches a limit. What did the limit do that it's saying?
Oh, you mean? Let me see if I can give you a better example. So you can convince the best.
Is the sigma, is that the same as the then?
Oh, you mean like these are the
Those,
same?
yeah.
Essentially, but I want to give you a more concrete example so you can see it. Okay, partial, here's an example. So this series is a geometric series, right? So we know it's like 1/2 plus 1/4 plus 1/8, okay? So let's just say that we can find the sum, okay, using geometric series. This is simply 1/2 over 1 minus 1/2. It's 1/2 over 1/2 is 1. So we know the sum is 1. Okay? Now, here's partial sum. The partial sum is adding incremental values. So you see it's 1/2, 3/4, 7, 8, 6, 15, 16. So if I just find the limit as it approaches infinity of my partial sum, I could tell that this pattern is basically just headed towards 1 as well.
So I sub n essentially equals just the sum of all the things that A.
Yes, yeah. So once we have the partial sum, we don't have to add the terms, it's already doing the adding for us. So we'll just find the limit as an infinity of this sequence, and that basically tells us the sum of the previous series. So you can
So the sum of the series is just the limit of.
That's right. The sum of the series is just the limit of the sequence of the S of n. Or how about this? A over x. Make this 15 is equal to put that and then the 5 that is 1 over 8 cross multiply. The place of norms. That's
Absolutely, one of the ones in your and it said, but I was just wondering that if you want to be taken seriously, it's density.
I think so. You're like, it's sweet, it's more complicated than that, than we've supposed to think it is the less than. Okay. Okay.
Then your comparison partner would be P series. Okay.
Maybe we're just super big. Everyone's big, but more than there's not. That's the whole thing. The whole thing ever just.
Okay, let's keep working for 5 more minutes.
Say for absolute value bars. Just ratio test and root test. You have to allow that.
Question.
that's why we serve. And if it's not enough case, what is. If it isn't case of the type. In my basic and aspiration, in the very consistent price price sharing, which real costs. Average not cancellation of the race. It's not going one house. Price clear trustee, I think, because it was already interested. There's another term after that, the state of this guy. Do you make this? It's, yeah, it's there to go from the original with us out. Then, a little bit, you can, like, you plus one, I can shoot it.